untapped secrets. Hidden beneath its waves are worlds within worlds. Over billions of years, the ocean has created endless varieties of life. Life that enchants us, that sustains us. And despite our science, life that mystifies us still.
The oceans are an incredible place, full of the most amazing kinds of life. Life that you could never imagine really working. Things that if somebody just thought of them and showed them to you, you'd think, that's ridiculous. Nothing like that could ever live. But it does.
In 35 years of diving, it's quite a picture. I've spent my life on the bottom of the ocean with black sea bass. I've seen white sharks underwater. I've been in schools of bait that would be so big that they will dark out the sun. I can only hope that the ocean maintains that vitality. It's an incredible place of mystery, and it's something that's beautiful beyond description.
People rely on the oceans in so many ways. Some ways are obvious, like food, recreation, transportation.
They clean our shores. They protect our coastlines from storms.
The oceans regulate climate and provide the world with most of its oxygen.
But we are now certain of one awesome fact. The ocean's power to create life is rivaled by our own power to destroy it. Scientists refer to ocean acidification as the other carbon problem. The first, of course, is global warming.
People have heard about global warming for years, but it's only over the past 5 years that experts really understood that the carbon dioxide is causing a problem for the oceans as well. And what's worrisome is it hasn't even been on our radar.
Carbon dioxide pollution is transforming the chemistry of the ocean, rapidly making the water more acidic. In decades, rising ocean acidity may challenge life on a scale that has not occurred for tens of millions of years. So we confront an urgent choice: to move beyond fossil fuels, or to risk turning the ocean into a sea of weeds.
When we burn coal, oil, or gas, we introduce carbon dioxide into the atmosphere. But the atmosphere touches the ocean over 70% of Earth's surface. So this carbon dioxide we're putting into the atmosphere, we are also putting into the ocean.
Carbon dioxide, or CO2, exists naturally in our atmosphere. Plants need it to grow. Animals exhale it in every breath. But carbon dioxide is also a byproduct of burning fossil fuels. And in large amounts, it is a dangerous pollutant. Since the Industrial Revolution, the ocean has absorbed roughly 1/4 of the carbon dioxide produced by burning fuels. Scientists once thought this beneficial. After all, that carbon dioxide would otherwise accelerate global warming. But what happens when so much carbon dioxide, 22 million tons of it each day, mixes with ocean water? In terms of chemistry, the answer is simple. It becomes an acid.
Since the Industrial Revolution, the ocean acidity is increased by 30%. With mathematical models, scientists have demonstrated that if we continue to pollute as we are now, The ocean acidity will double by the end of the century compared to pre-industrial times. That is a big problem.
Scientists only recently stopped to think about what this would mean for life in the ocean. Thousands of ocean species build protective shells to survive. Some are so prolific, they can be seen from space. These organisms create their shells, which can be paper thin, by drawing certain molecules from the water around them. But rising acidity depletes those molecules.
So by removing the essential building block for shell formation, it's making the organisms work a lot harder to build their shells, and that means they have less energy to get food, they have less energy to reproduce, and eventually the organism can no longer compete ecologically. The surprise is how sensitive some marine organisms are to this increased acidity from carbon dioxide.
And when acidity gets too high, shells dissolve.
We're changing the basic rules of everything. And because of that, a lot of organisms may not be able to survive.
Already, we've seen water showing up off the coast of Northern California that's acidic enough to start actually dissolving seashells. It's thought that this kind of corrosive water showing up will become more and more common.
Most of the west coast of North America's shellfish, that's Dungeness crabs, lobsters, mussels, oysters, sea urchins, shrimp, all those life forms are at risk.
By mid-century, if we continue emitting carbon dioxide the way we have been, entire vast areas of both the Southern Ocean and the Arctic Ocean will be so corrosive that it will cause seashells to dissolve.
Scientific models show that in just a few decades, we will profoundly alter the ocean's chemistry. Such conditions haven't existed since the extinction of the dinosaurs. Recreating those conditions so quickly could leave many ocean animals unable to adapt. What if shellfish could no longer build shells? Would they cease to exist? Perhaps. Shelled creatures such as corals and plankton play a key role in the ocean food web. Pteropods are a kind of plankton that live all around the world and in great abundance in polar waters. Pteropods are especially vulnerable.
Okay. Should I focus in that?
Yeah, maybe
Right in there.
We're looking at pteropod shells, which are planktonic snails with a calcium carbonate shell that we collected from Antarctica this past winter. And you can see it looks like there's this lip where it may have already started to dissolve and kind of curled over, because that's what it looks like when it dissolves. It kind of melts, almost like a candle and wax melting. The shell thickness along the leading edge right here is less than 1 micrometer thick. These are the thinnest pteropod shells I've ever seen.
There's growing alarm that higher acidity will extinguish creatures like pteropods that are a basic food source for fish. In many parts of the world, fish are a basic food source for people.
So you can't just worry about the big things in the ocean, you have to worry about what they eat and where their food comes from. if the smallest things in the ocean are affected by ocean acidification, then it ripples all the way up the food web, making the largest things in the ocean even more in danger.
As individual strands disappear, the entire food web becomes weaker, more vulnerable, less beneficial to humankind.
And many of us are concerned about what that means for the Earth's marine ecosystems, but also for the many millions of people that depend on these systems for their food and income.
Ocean acidity will rise most quickly in cold water regions and areas where deep water wells up to the surface.
That is disconcerting because it coincides with the regions of the most productive fisheries in the world.
I'm a fisherman. Every single day I have to make a prediction where I'm going to go fishing, whether I'm going to find fish where I go. And every single day, the decisions I make the difference between whether I stay a fisherman and make a profit. I can make predictions. I think these things are dire problems. Either we change what we're doing on land, or it will have profound effects on fisheries as we know them.
Marine life that might withstand warming temperatures or rising acidity may succumb when confronted by both. Coral reefs already struggle to survive in warming waters. Rising ocean acidity puts them in double jeopardy.
We know that coral reefs are particularly sensitive to ocean acidification, and the reason for that is that corals are unable to form their skeletons as quickly as they used to, and reefs are starting to crumble and disappear. We may lose those ecosystems within 20 or 30 years. And in those structures live an estimated 1 million species. 1 in every 4 species in the ocean lives on a coral reef. We've got the last decade in which we can do something about this problem. But it's very, very clear that if we don't start to deal with it right now with very, very stern cuts to emissions, we are going to condemn oceans to an extremely uncertain future.
We're really in the last decades of coral reefs on this planet for at least the next, say, 1+ million years, unless we do something very soon to reduce CO2 emissions. We're moving from a world of rich biological diversity into essentially a world of weeds.
Today we're in a really remarkable history of the ocean. 100 years ago it was inexhaustible. You couldn't touch it, you couldn't harm it. In 100 years, it might be dead.
When people say it was high CO2 100 million years ago, so we have nothing to worry about, that high CO2 was achieved over a slow process of millions of years. And if we achieve high CO2 over millions of years, the Earth will be able to handle it. If we achieve high CO2 over decades, the ocean is in big trouble.
Earth is the only planet we know of where life exists. To understand our own actions, we sometimes need to view them in a larger context. Planet Earth was formed 4.5 billion years ago. 3.5 billion years ago, life began. 250 million years ago, dinosaurs appeared. And 200,000 years ago, Homo sapiens. Within that framework, human civilization is brand new. Our industrial society, but an instant. Yet in that instant, we have altered the course of nature. We have heated the Earth's surface, acidified its oceans, and consumed much of its natural habitat. Now, something extraordinary looms. A mass extinction of animals and plants, caused not by volcanic eruption or the collision of a meteor, but by the actions of one species, ours.
If we destroy these ecosystems, it will take millions of years for them to recover. It's as if somebody, just because they had the ability to do it, decided to run through the Metropolitan Museum with a knife, slashing the great paintings of the world.
We have created this problem. We should be able to solve it. The ocean, after all, is resilient. Given the chance and enough time, it can heal itself. So how can we give the ocean that chance? Marine protected areas, like national parks in the sea, shelter ocean life from industry and development. Sustainable fishing practices allow fish stocks to regenerate. The ocean can better defend itself against rising acidity and temperature if its systems are healthy.
To make the oceans more resilient to these changes, we need to do a better job of keeping the oceans healthy. That means restoring depleted fish populations, establishing marine protected areas all around the globe, and reducing pollution, particularly nutrient pollution, in the coastal zones.
Solving those local problems gives those ecosystems a chance to survive, a chance to make it through while we solve the global problem. We know how to solve the local problems of marine ecosystem health. We know how to solve the global problems. The question is, will we?
The only way to stop acidification is to emit less carbon dioxide. Our Industrial Revolution began more than 2 centuries ago. Technology has advanced rapidly since then, but we still make energy as we have for hundreds of thousands of years, by setting things on fire. Often, we squander the energy we make, using more than necessary to accomplish our goals. But now we know how to use energy more efficiently, how to do more with less.
There was a time when people thought about energy efficiency and conservation as sacrifice, doing without, dark homes, shuttered economies. That is emphatically not what we're talking about. We're talking about getting dramatically more work out of less energy with better technology. Those energy efficiency solutions are particularly promising because the whole world will want to adopt them. If we take that initial step, we will also, in addition to reducing carbon pollution, have the very welcome dividend in the form of economic stimulus because we'll be reducing energy bills.
We know how to capture energy cleanly from sunlight, wind, tides, and the heat of the Earth's core.
Imagine that you're living in a house that gets some of its electricity from its own solar panels, feeds some of that back into your own vehicle when it's plugged in at night, provides you with energy services, and maybe this is the most important single piece of it, at costs below those you're paying now. That double dividend was never more needed by the U.S. and world economy than it is right now.
We are on the verge of a green industrial revolution, a revolution that will expand our economy, protect our resources, and give us real energy independence. There is much we don't know about how carbon pollution will affect our world. Still, we have to choose. We can go on as we have, forcing future generations to survive somehow without the vast ocean resources that have sustained us. Or we can move beyond fossil fuels, securing a future that works for all of us, for all living things. What will we choose?
You're not going to use this, I'm going to just say it though. What makes a Greek tragedy is that you can see it coming. Oedipus, goes and marries his mother and eventually tears his eyes out, and you want to tell him, look, no, don't marry your mother. You can stop this process now.
And you think, if I could only go back and change that one little tiny instant, then things would have been different. I think we're in that instant right now.
We sit by feeling almost helpless because we see this unraveling leading to its tragic end.
Researchers are predicting significant and substantial changes in the next 2 decades to our oceans. So it is not necessarily a problem we're passing off to future generations. It's a problem that we're generating for ourselves.
I think what gets me up in the morning is that I don't want to see coral reefs disappear on my watch. And I know that my fellow scientists feel this way as well. So we feel compelled to communicate the message that this is a serious issue and that changes that haven't happened for millions of years are starting to happen right before our eyes. I think it's important to point out that it's not all over yet.
I don't expect people to understand what pteropods are or what various forms of plankton are likely to survive or not survive. But I do expect our policymakers to take serious an issue that is so closely tied to life on this planet and the future of life on this planet. I have hope. You can't fish and not have hope.